This is Professor Needing, and we are on section 19. We're almost at the end, folks. We are calculating statistics. Talks about when we calculate statistics. What we're looking to do is we're looking to find a numerical value of a test statistic. So remember, we're going to want to go back to our original formula sheets, and we're going to want to be able to look at the hypothesis testing in order to challenge another application of the order of operations. It says another challenges order of operations. So in this particular one, it's all about getting the stuff into the calculator properly and letting the calculator do the work for us. And I'm going to try and just use my desktop shot here instead of going back and forth to the computer on this one, because there's a lot of writing to do in this one. So let's do example number 1. So it says, first of all, substitute the values in the formula. So let's look at what we got here, first of all. For example, the steps for finding the value for a test statistic when the proportion, okay, so we know we're using a proportion, in the sample data, p hat equals 0.61. That's our best statistic that we have, and we know it's a p hat value right here. The proportion of the claim is that p sub 0, remember null, is 0.5. And the sample size is n equal 1,000, and rounding the answer to 2 decimal places. So we're gonna find that value, okay? All right, so we're gonna test against this particular claim and just get a test statistic right now. So first of all, we substitute in some values. So let's take a look at what we have. So our original formula is z, test statistic, for this proportion. We'll take the single proportion, p hat, we'll subtract the null, we'll divide it by the square root of the null, multiplied by 1 minus the null, divided by the n value. So what does it look like when we do that? So it looks like this. It looks like 0.61, that was our p hat, minus 0.5, because that's our null, divided by, again, our null, multiplied by 1 minus null, which is, yeah, it's 0.5, but I'm going to enter it in here so you can see what we're doing, divided by 1,000. All of this value has to be under the square root. So what I want you to try is I want you to try putting this into your calculator to where it looks like this and see if we can get this particular value right here. I'm going to open up my calculator, and I'm going to put mine on the screen right next to what we're doing. And I'm going to talk as I enter values here. So the first thing I'm going to do is I'm going to hit a fraction. And for me, the shortest cut is alpha. And right next to alpha, that opens up the fraction key. When I do that now, I want to put in 0.61 minus 0.5. I'm going to scoot down. I'm going to enter now a square root first. So I'm going to go second, square root. Inside of that square root, I need a fraction. So again, I'm going to go alpha. And right next to alpha, the x, get a fraction. 0.5, parenthesis, 1 minus 0.5. Make sure you're using the proper subtraction sign. Scoot down, 1,000. And I'm going to hit enter. And I hit a decimal wrong. I missed 0.61. So, hey, this is a good learning opportunity. What did I do wrong? Can you see the 0.6 is supposed to be a 0.61 right there? So I don't want to retype all this. I'm going to go to second entry, which brings up the line. I'm going to scoot back over. I'm going to go up into the problem. And I'm going to change it. I'm going to go second, insert a 1. So I was able to change my value, hit enter, and I get the proper answer. I'd like to tell you that I did that on purpose so I could show you how to do that, but my fat fingers, I just hit the button wrong. Okay? But at least I knew that I had something going on in there. Practice with your calculator. So we would round that answer accordingly. It says we round it to 3, and because it's 957, we can just simply take that value. And if we're rounding to 2 decimals, then we'd go to 96. If we were keeping 3 decimals, we'd keep 957. But it did say to round equivalently to 2 decimals, so 6.96. Important to note that this is positive, meaning it's on the right-hand side of the 0.5 null that we had for our original value that we were going to be centered up on. All right, page 94. Let's keep going. In page 94, and I have to get that there. Give me 1 second. I'm cruising along here. Sorry. In page 94, we have a couple of problems that we're gonna try here. And so let me get this centered up nicely so you can see it all. So let's get our values that we need and what we're working with. So first of all, for each of these, we're finding a test statistic. Okay. So we're going to need to go back and we're going to have to be able to grab our original values of these. So we have student exercise number 1 says H sub O. We have P equals 0.5 versus H of A, P greater than 0.5 using the sample results of P hat 0.57 with an N value of 40. So we're talking about a Z statistic. Okay, and that Z statistic is going to, and go back to your sheet and find your Z statistic for your single proportion. And it says that we should take the proportion P hat, and for us the zero proportion is P hat is 0.57. We're going to subtract the null, which is 0.5, and I get that from right here. H of O, nothing going on. I'm going to divide that by the root of the null, 0.5, times 1 minus 0.5. And then I'm going to divide that value by n, and that n is going to be 40. I'm going to pause the video for a moment. Here we are again. I'll show you my calculator real fast. 0.57 minus 0.5 divided by the root of, make sure everything is under the root, and 0.885. I don't know how many we're rounding to, but I'm just going to go ahead and leave that Z statistic at 0.885. You can round accordingly. Again, I have a positive Z statistic, so this is a Z score centered up at a 0. 2 standard deviations left, 2 standard deviations right. I am little less than 1 standard deviation to the right-hand side of the null at 0. Student example 2. So we have an H sub O of mu, so we have a mu value here. We don't have a proportion. We have a mean of 120 versus less than 120. So we're testing to see if we're less than this value. Using the sample statistic, here's my stat, X bar, 111.23 with a standard deviation of 18.4 and an N value of 100. So my formula is going to be my T, because I'm dealing with a mean. It's a single mean. I've got X bar minus my nothing going on value divided by my standard deviation, which is then, in fact, divided by the root of n. So if I fill in those particular values, I have 112.3, which was my statistic, minus my mu value of nothing going on, 120. I'm going to divide that by my standard deviation of 18.4, but that first has to be divided by the root of my sample space, and even though it is 10 when you take the root, I'm going to write the 100 in there. Again, take a moment, go do the calculation, and I'll have it right for you in a second. I'm back with you, and you can see that in my last calculation here, 112.3 minus 120 divided by the entire fraction of 18.4 and the square root of 100, which really is 10, gives me a t value of negative 4.185. Negative 4.185. And again, let's start thinking, where is this? This is left of the center on a t distribution. And you haven't seen a t distribution, but it's very, very similar to a z distribution. Student exercise number 3. First of all, we have H sub O at mu1 equal mu2. Remember, though, that's the same thing as saying mu1 minus mu2 equals 0. And our null is countered by our alternative at not equal, two-tailed design. Using the sample statistics, here's our first x1, and here's our standard deviation for it with this set of n. And our second piece of data, so we have 2 means here. We have 18.4 with a 14.3 standard deviation and an 80 count on the value. So our formula is for a t distribution for 2 means. So in our formula, if you go back and grab it, practice getting that before I write it down. Also, at the same time, you can stall the video anytime you want. We're going to take first mean minus second mean minus null. And we're going to divide all of that by the standard deviation of the first square divided by n1 plus the standard deviation of the second square divided by n2. So we're going to fill in the blanks. 15.3 is my first set, minus 18.4, minus 0, null, root of my standard deviation. It's important that you use a parenthesis for your squaring. And my first set was 100, plus my second standard deviation, which was 14.3, and again a parenthesis before I square, and I had an n value of 80. I encourage you to pause right now and come back to me and see if you get the same thing I do. And you can see that my final result was negative 1.569. My t-value was negative 1.569. Again, indicating that I am left of the distribution because of the negative value. Student exercise 4. In student exercise 4, we're testing hypotheses for proportions, and you can see right away if you start digging through the data, we have P1 and P2, so we have P1 and P2, which means we have the difference of two proportions. So take your second, go off to the side, find your formula. My test statistic is going to be P hat 1 minus P hat 2 minus 0. All of that's going to be divided by, notice this is the one where we have a pooled proportion. And we're going to have P hat, I know it's a pool because it doesn't say P1, 1 minus P hat, divided by the number of values in 1. And it's going to be P hat 2, or excuse me, P of the second set, and it's 1 minus P hat again, and it's divided by the n values of the second set. The only thing that's actually come from the sets are n1 and n2. Pool is going to be a separate calculation we're going to do here on the side in a second. Matter of fact, we're going to set that one up right now. So for us to get the pool proportion, P hat, well, first of all, we got to remember we have to take from the pool proportion, we have to pull the proportion of and the number of. The proportion of and the number of values divided by n1 plus n2. And we have to add that to the second proportion times its n value. We got a lot of calculating here. So this is the one we have to do first. We need this one before we can do this one. So in our first proportion, we know that we have a 0.4 proportion times 382 items. Plus, in the second one, we have a proportion of 0.6, and there were 192 items, or n counts, if you will. And that has to be divided by the sum of that 382 plus that 192. We need this number before we carry on. So I'm going to give you a second to get that number. So I went ahead and I put those values into my calculator, and I got this decimal that you see. And on some circumstances, it would be okay to take this at 0.467. Okay, I don't like to do that too much. I like to keep the actual value, and this is an irrational number. So I'm going to go to my math button. I'm going to change this into a fraction, number 1. And I'm going to tell it, hey, can you give me a fraction for this number? And it can, 134 over 287. I'm going to keep that number. So I'm going to keep 134 over 287. If the problem said to round intermediately, I would go ahead and round that number. But I'm going to keep this. So what's that mean for me up here? All right, well, when I do my calculations for this formula, I now have to go fill in my values for P hat and P hat 1 and P hat 2. P hat 1, 0.4. minus 0.6. I'm not sure why I put parentheses around there just now. Remember, we're taking away 0 here, so it really doesn't matter. Now on the bottom, it's square root. It has nothing to do with P1 and P2. It has to do with 134, 287. So I'm going to have 134 over 287 times 1 minus 134 over 287. Plus, again, that exact same thing, right? Because it's going to be identical on the other side. The only difference here is the pooled values that are underneath of these. I need to take away I made my fraction bar a little too long right there. So my first one, N1, was 382. And I'm going to repeat everything you see in the right-hand side. And I'm going to divide this by the opposite one, which is 192. Go ahead and take a moment and go get that. So I'm back, and like you, my opposing thumbs are kind of locking up after entering this into my calculator. And so I'll give you a second to take a look at it real fast, but you can notice it wouldn't have been nearly as difficult if I didn't have to enter the fraction 134 over 287. And in probably 90% of the cases, it would have been okay to take that decimal approximation of 0.467. But I wanted to be as accurate as possible, so I left that fraction in there. And sometimes that accuracy can make the difference in being right and wrong inside of Wiley. So if you're getting an answer wrong and you swear you're doing it right, maybe it's because you rounded a decimal. And if I do my enter, I get negative 4.531. So my z statistic is negative 4.531. And remember, now we also know how to test this, right? And we know how to get a p-value from here. I mean, right here, if we were to take this statistic and see, well, what's its p-value? You know, we could do a normal CDF. And from that normal CDF, we could calculate this value. And so I encourage you to go and remember that in your calculator and go perform that function of that normal CDF. But remember, this is a two-tailed test. When you get your answer, multiply by 2. Because the area that this produces left of it will be multiplied by 2 because it's a two-tailed test. And it's a two-tailed test because it's not equal. I decided I would do that for you just so you could see that. So first of all, I'm going to go to my distribution function. I'm going to go down to my normal CDF. I'm going to punch in my left small number at negative 1 E99. I'm going to put in the test statistic I just found, which was the Z number. I'm going to put in mu at 0 and standard deviation at 1. I'm going to hit paste. And remember, this is going to find the proportion, probability, the area left of the statistic that I have. So what's outside of that normalcy, if you will. So again, remember, if you receive something like this with a negative 6, remember, this is a number with 6 decimals moved this way. So take a decimal and move it this way 6 times. Put 5 zeros over here, and that's how small this thing is. But remember, I got to hit times 2 because it's a two-tailed test. But it's still basically this p-value, which is negative 0.00000, 5 zeros, and a 5 or a 6, depending on if you round right there. Incredibly small p-value, very small percentile of things which are actually outside of that. And that's why we're finding this z-test number, so that we can take this z number and we can put it into this formula, and then we can calculate the area and we can test the probability of this number actually taking place. Not this number, but this difference of 0.4 and 0.6, how different they are. All right, last one. Oh, no, not last one. Student exercise for number 5. So student exercise number 5, we have H sub O, we have a p-value of 0.3, and we have a p-value of less than 3. So we have a single proportion. Easy. 0 equals. And remember what we're looking for here. We're looking for the first value, p hat, 0.21, minus the null, nothing going on, 0.3. We're going to divide all of that by the root of, again, 0.3 times 1 minus 0.3, and all of that divided by our n value, which is 200. Okay, I'm going to pause and let you get that. So when I do the math on that, I get approximately negative 278. So my z number is approximately negative 2.78. Now I want to go take this z and I want to find its percentage of its p. I want to find its p-score. P-score, right? What's its probability of this happening? Okay, well, I'm going to go into my calculator. I'm going to go to second vars. I'm going to go to my normal CDF. Remember, I'm squeaking down negatively because I'm going, this is a left tail test if you look at it. It's a left tail test, and my number is negative 278, so I want the area to the left of 278. I mean, if we drew this kind of quick, I'm looking for when will 0.21 happen? Remember, the center of the statistic is 0.3, null, nothing going on. And I have a 0.21. And I'm looking to see what the percentile is left. Well, now I have a z-score of 278. So on the standard normal curve at 0, I have a negative 2.78, and I'm trying to figure out, okay, what's the percentile of that value? So I put that into my calculator. So I go downward, and I put in that negative 2.78. I don't double this number because it's not a two-tailed test, it's a single-tail test. So how about 0.003? I have a p-value of 0.003, much less than any alpha score that we've looked at so far. Last one. I think you should pause right now. I think you should go try and do this problem, and then I think you should come back and see what I have. So first of all, I have mu, and I have x bars, so I'm dealing with a t-score. I have two different x's, x1, x2, so I have the difference of. So I'm going to use a t-distribution. I'm going to take the first value, 56, and I'm going to subtract the first value, 51, minus the mu. I'm going to divide that by the standard deviation square, 8.2 square, and that sample set was 30. My second one is 6.9 square, and my sample set was 40. Put that through your calculator, run it through, get your values. 2.699, I think. Then I want you to put that into your calculator, and I want you to do a test on its proportion. Now remember, this is a greater than proportion. So if we think about what that is, remember on this distribution scale, we have a 2.699, and we're looking to go this way. Okay, so I'm going to pause and let you go get your value of your proportion. You should have calculated a p-value at 0.003, and although we weren't asked to test, right, just kind of do the things, if I were at any kind of alpha level, I would be rejecting the null based on having significant evidence because of the test statistic I have. And for the last two exercises, exercise 7, first of all, we have h sub o at mu equal 4 and h of a at mu not equal 4, so it's a two-tailed test. We have x bar, mean, at 4.8, standard deviation, and a single population, or a single n count. So what we have is a test for a single mean. We have a test statistic for a single mean, which is x bar minus the null divided by the standard deviation and the root of n. For us, the values are 4.8 x bar minus nothing going on, 4, divided by 2.3. And the 2.3 is being divided by the root of n, and the root of n is 15. On this exercise, we're going to calculate, and we're going to be given a t-score, 1.347. Remember that this test that I'm doing right here, if we're going to continue on with this test, I'm looking at not equal, so I'm looking at a two-tailed design to get my p-value. So if I want my p-value, TCDF, I have a 1.347. I'm heading off to the right side because of the, that's the one I'm checking. So I'm checking right side, but I know I'm going to multiply by 2. I could also check left side, but this was a positive value. And since it's a positive value, it makes sense to go to the right. If it's if I'm going left, I have to take away that in-between area because it's going to go back down to 0 and go to the other negative 1.347. And I'm going to now, new number that we'll be calculating that you're not quite sure of yet is the degrees of freedom. And the degrees of freedom, as we'll talk more and more, come from the smallest of the sample, 15 minus 1. This n value is always decreased by 1 to get the degrees of freedom. And then I'll answer by multiplying that question by 2. P-value, 0.199. Last exercise, number 8. We have a P1 and a P2, so we have a difference of 2 proportions. So right away, it's the z statistic is equal to p hat 1 minus p hat 2. Subtract the null. Divided by p hat 1 minus p hat. When I'm saying p hat, I'm meaning pooled proportion. Plus pooled proportion 1 minus pooled proportion divided by n2. I did the pool proportion calculation already, and remember in your pool proportion calculation, you're going to take the proportion of the first, 0.48. You're going to multiply it by the number of 75. You're going to add to that 0.28. You're going to multiply that by the also 75, because both sets had 75. And you're going to divide it by the sum of those two 75s, which is 150. And this decimal came out to be okay at 0.38. So I'm going to utilize that 0.38 here, 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 and here. And I'm going to replace p hat 1 and p hat 2 with these same numbers I used right here, 0.48 and 0.28. So my z statistic becomes 0.48 minus 0.28. Take away the null. Divided by root of, I'm going to use 0.38 times 1 minus 0.38. My first set was 75, and so was my second set. So my two fractions are going to look super similar, because they are. And divide by 75. Take a pause, take a breath, stretch your arms. Might want to do some yoga right now so you don't pull a muscle. And when you do your z value, your z value is 2.523. You can use this z value, and you can go calculate your statistical probability or your p-value to the right of this. Because remember, the original calculation was things greater than. Do not multiply this by 2 when you check its p-value. Because when you're on your distribution, your z statistic from center 0, you're at 2.523, and you're checking everything to the right of that for its area.